And yeah, so the first thing we're going to do is add some controls because right now we can see this scene, but we can't move it. And when it comes to developing stuff in 3D, we really want to be able to move the scene around to see everything that we might want to be, every perspective on the scene so we can see how it all fits together. Hey, Francis, I think we've got a little echo if you want to. Thank you. Thanks for muting. We are just getting started. We just kind of reviewed code from last week, and there's a link to the code in the messages. Um, sorry, were you saying something? Okay, that's fine. Okay, no worries. If you want to just mute so we don't hear the echo, that'd be good. Okay, that sounds fine. So, um, I'm not sure. I don't know if we can't really hear you, or at least I can't. Uh, okay, Francis, if you want to mute, I guess I can I'll mute you for now. Um, okay, thank you. Okay, cool. Sorry about that. So yeah, Francis, just to catch you up, we just reviewed the code from last week. There's a link there if you wanna click on that and see where we were, or if you have Glitch open, you can open it. So a few people were having some issues opening Glitch, including me, but they seem to be resolved now. So if it's not working, you might want to try like an incognito window in Chrome, if you're familiar with that. But we can also, if you want to just watch this part and then work on it later, we can troubleshoot later as well. Okay, so yeah, let's just get back to it. Let me know if you have any questions. Um, okay, great. Um, so yeah, so we want to be able to move around the scene to be able to actually edit our 3D. And we're going to make kind of a version of what you see in the Three.js editor. So I'm going to go over to Three.js.org, which is obviously where we're going to be always, as long as we're working with Three.js, we're going to be spending a ton of time here. And if you go to the editor, so I'm going to open this in a new tab, you can see that when I click and drag, um, I can rotate around the screen, and we see this kind of plane that shows us the orientation of the scene. And if I scroll on my scroll wheel, I can zoom in and zoom out. And if I right click and drag, I can what's called pan, which is just moving on the X and Y axis. Um, or depending on what scene you're looking at, or what perspective you're looking at, it may be the Z axis. So if I change the perspective, now I'm panning on Z. But anyway, we just want to put these controls in our scene so that we can edit the scene as we're working on it. Depending on what type of project you're making, you may have the camera moving like in a circle. It may not necessarily be interactive, but as long as we're developing the scene, we want the ability to move around in the camera. And it's also going to show us, it's going to be a good way to go over how to add components in Three.js. So one of the things about the Three.js library is that it's very complicated. There's a lot of different parts. And so they don't put everything into that one Three.js file that we already downloaded because it would be way, way, way too big if we did. So remember, I'm going to go back to Glitch for a second. We downloaded in our JS folder this 3.min.js, and that's this big file. I don't know how big it actually is. It's probably like 500 kilobytes or something like that. But it's a really big file, but it doesn't even have like most of the Three.js library. There's a lot of other components that go into it. The reason Three.js is just one file to start is because it does all the basics. Every 3D scene has to have certain basics like the geometry, the cameras, things like that. But some scenes use some components like the controls that we're going to add, and other scenes may not need them. So in order to save space with loading the library, we don't put every single thing into the library to start with. So part of this is adding controls, but also part of it is going over how do I add a component into a Three.js project. So those are both things that we need to know how to do. So we want to add some controls. We're going to have to add another JavaScript file in here, and then reference it in our script file. So if we go back to Three.js, I'm going to go to the documentation, and I'm just going to look up controls and see if there's an easy way to get started with this. So you can see there's a bunch of different types of controls. And all of these controls are good. The one that's being implemented in this scene is called orbit controls. So that's what we're going to do to get started. But the other types of controls are also useful. We can actually look at some examples. So if we go to controls in the examples, um, this is like, this is called arc ball. This is a controller for an object. So if we want to be able to just view an object, we can give it this little ball, and you can see I can rotate it. I can pan the object, and I can probably zoom the object in and out. So instead of zooming the whole scene, I'm just zooming this one object so I can see the details. Um, this is a drag controls. So in this case, the camera stays in one place, and you can see I can actually click and drag on the objects in the scene. So that's pretty useful for different types of projects, but we're not going to use that today. Then controls fly is kind of a cool one where it's always like moving a little bit, and it moves depending on how far our mouse moves from the center. And then we can also roll and move in and out. So it's kind of like if you were flying a spaceship or something like that, which I think is why they put us in this scene with the planet here. Um, and I think I can, oh yeah, I can move like that as well. So that would be good if we were making like a, a spaceship type experience. Let's see if I can actually get under the clouds. I've never actually done this before. It is 2 layers though, that's pretty cool. Anyway, that's fly controls. Um, Map controls, this is like similar to what we're going to be using, but it's a little bit farther away, I guess. Actually, I don't really know what the difference is. Oh, I guess it's like it's based on acceleration, like it kind of animates around instead of going exactly with my mouse. Then the orbit controls is what we're going to do. I can pan and rotate and scroll in and out. This is probably the best one to use if you're just working on creating a scene because it's pretty straightforward. Um, we can kind of change our pivot point and look at different things. There's also pointer lock controls. This will remind you guys of like first-person shooter style games where I'm using the WSD keys to move the camera in the scene, and then I'm using my mouse to change the perspective. So this gives me this first-person perspective type view. And this scene is kind of like just a simple little platformer. So that's the pointer lock controls. And the tricky one about this is that you have to click to get it started because now it controls my mouse and I have to hit escape to get out of here. A couple more, the trackball. This is also similar. It just kind of rotates a slightly different style of animation. Um, and it has a little bit of a different look. And then we can also use the transform controls, which allow us to move objects in the scene and stuff like that. So anyway, we're going to do the orbit controls. And there's different ways to like find this stuff and add it into the scene. There's not like one specific way that you have to do it. Um, but we can, there's a couple ways to kind of figure it out. So we can click on orbit controls, and then you can click on the little brackets down here, and this will show you the controls in GitHub. So that's one way to do it. We can look at the code here and figure out where it is and go from there. We can also find it in the documentation. So if I go back to the docs and go to orbit controls, this will usually have some code that shows me how the orbit controls work. And this is a lot simpler, so it's a little bit easier to use this. And then it'll usually have a link at the bottom to the actual code source. So this is a slightly faster way to get this into our project, just because we see a simple version in the documentation, and then we see the link to the actual code itself that we have to add to our project. So that's a little bit more of a straightforward way to get those controls. Again, we'll look at this with other components as we add more stuff into the scene, but that's usually how I would do it is on the Three.js website, inside documentation, just looking for the component that you want. So we're going to type in controls and go to orbit controls. And then if we scroll all the way down to the bottom and type on this and click on this link, that'll take us to the original source file. So there's a tricky part here that I'm going to go over now. So I have the source file here, and I'm not going to share this quite yet because one thing that's a little bit confusing for sort of not completely introductory, but sort of second semester programmers is that there's two different ways of programming in JavaScript. One is just pure regular JavaScript, and the other is more modern versions of JavaScript, which have added more features. And the main Three.js library is written in a more modern style, which is good if you have a lot of experience, but it's harder to learn if you haven't been using it already. So one thing that we're going to have to do, and fortunately it's not too hard, is that essentially Three.js has organized the code into two different parts. And you can see that if you go to Three.js and then go to examples, there's JS, which is JavaScript, and there's JSM, which is modern JavaScript, or ES6 is another shorthand that people use for it. And what we wanted to use is the JS, but most of the examples use the JSM version. And the nice thing about the way it's organized is it's easy to find that file. If I go back to this file, there's a JSM right here, and all I have to do is change that to JS. If I take out that M, as long as they have the same file in both places, which is true, I think, like, 3/4 of the time ish. Some things don't translate. But if I just take that JSM and turn it to a JS, now I have the regular JS version of these orbit controls. And this is on GitHub, so we can see the code here, but what we need is just the raw version of this file. So if I click raw here, that takes me to the file I actually want. So it is a little bit tricky to find, so that may be kind of annoying, but there's our code. We can see all of it, and this is what we can actually use in our project. So I'll put a link to this in the class chat, and I'll try to remember to put it in the YouTube video as well for later. So I'll just leave it here. And again, we can just link directly to this with an external link, so I don't actually have to download this and re-upload it to Glitch. I like to keep things kind of organized that way, so I'm going to download it, but either way works. So to download this file, I'm just going to hit Command S to save it, and I'll save it to my downloads folder. I have a bunch of stuff in here. I need to clear this out, but I know it's called orbit controls, so it should be relatively easy to find. And finally, I'll go back to my project over here, and I'll go to JS, and can I add a file here? No, I have to, oh yeah, add file to folder, upload a file. I'm gonna find orbit controls, click open, and it put it here, so I'm going to rename this and just put JS at the beginning and a /, and that will add it to my JS folder. So that's where I want it to be, so it's a little bit more organized. And so those are the steps to add it. Now that I've added it in here, if you're looking at my version of this site, you can just refresh it and that file will be there and you can remix it. So if you don't want to go through all those steps on your own, you can always just remix the examples that I'm adding on here. Okay, now I have to attach this to my index.html. There are a lot of steps to this, but eventually we'll kind of get used to it. So here last time is where I demonstrated adding in a external link to the script. So you could do the same thing here. You could just link to this URL. So I'm not going to rewrite this whole link, but I'll just put a comment and put the orbit controls here. So you can always just link directly to the original, but as I mentioned, I like to keep things nice and organized, so I like to put it in my own project. So I'm going to add in this script. I'm just going to say script source equals, and it's in this JS folder over here. So I put quotation marks JS / orbit controls.js. And then I just close the script tag, and that's all I need to do. Now I have the orbit controls. And so I have to just go back to the documentation and get the parts that I need to add this into my scene. So yeah, again, if you don't want to if you want to skip all these steps, you can just remix this new version of the sketch, which is at the same link, but should be updated now. So I'm going to close this and go back to script.js. And now I'm going to come back to the orbit controls in the documentation. I'll put a link to this as well in here. And so now I'm just going to copy and paste code. And so you can see a lot of this stuff we already have. So I'm just going to ignore this. We already have a renderer. We already have a scene. We already have a camera. Here's our controls. Okay, so I'm going to take the controls and I'm going to copy this line and go back to my app. And you can see that the controls references a couple things. It references the camera and the renderer. So if this is going to work, it needs to come after the camera and the renderer. So I'm going to go after the camera, go after the renderer, and paste in this line. And so we have const controls equals new orbit controls. So the camera matches the camera. So that works because I've been using similar examples from the documentation. If for some reason you named your camera something else, if it was like cam, you would just need to make sure that this matches. But since they match already, I don't need to worry about that. Same thing with the renderer. This is just a function, variable name. You don't have to call it renderer, but most of the time people do. So we just have this render.dom element, which is really a shorthand for our canvas. So we've created the controls, and then now we just need to update the controls. So you can see right here it says controls.update, and that is part of the animate function, because remember the animate function is what's making the animation work. It's what's rendering the scene over and over again. So that's kind of what makes our sketch work. And so I just need to paste this controls.update into our already existing animate function. And now we should be able to use the controls. Uh-oh, I have an error. Let's see what it says. Orbit controls is not defined. Oh, okay, that's the other difference. It's kind of good actually that I made this mistake instead of remembering to do it. So the other annoying, unfortunately, difference between the new modular version of Three.js and the older version of Three.js that we're using is that the new modular version, you don't have to put 3 in front of everything because it uses JS modules, which would take a long time to explain why that is. But for us, we just have to put the big capitalized 3 in front of everything from the example. So because this example is not written for the old version of Three.js, it just has orbit controls by itself. So we just have to say this. We have to say 3.orbit controls. Another way that you could do this, if you don't want to do that for every new thing, is you could say something like this: const orbit controls equals 3. And what this does is it will actually kind of like take this orbit controls thing out of 3 so that you can just reference it by itself. This is like, this will save you some time because you can add other stuff in here. Like you could put box geometry in here as well. And so then you could get rid of this 3 as well. But honestly, it would probably take me too long to explain how this actually works. So I'm just going to comment this out and add in 3 here. And that should fix our error. So let's refresh. Okay, so no errors. And now if I drag the mouse with the first mouse button, it's going to rotate around my scene. So that's pretty cool. And if I left click, it's going to pan the scene. Okay, so I can move the scene and then rotate. That changes like the origin position of the scene. And if I scroll wheel, I'll zoom in and out. So for working with 3D stuff, you don't really need an external mouse, but I'm usually using an external mouse that has a scroll wheel. I assume most of you guys are familiar with what that looks like, but it should also work on a trackpad. It may just be a little bit more kind of clumsy. But anyway, that is how we add in our controls. So there's a lot of steps there. It's not really like coding per se. It's kind of just like throwing crap around to make sure it works. But that's basically how we get that set up. And it really is like very, very simple. Like it's just one two lines of code, which is pretty nice considering how much work it's actually doing, how many different things are actually going on in order to make that work. Okay, so I'm going to pause for a second. So remember, again, if you want to copy and paste this code or remix this project instead of like going through all of those steps, you can always do that. Just go to the link that I posted before and just click on the remix button, and everything should come over with that. Um, okay. Any questions before we continue? Okay. Um, okay. So we're gonna work a little bit more on just building out the scene today. So I'm just gonna add in a couple things, and then we'll add some lighting and some materials on Wednesday. And that should give us enough to create like a really simple scene, and then we'll just kind of build from there. So I'll probably do like another, I don't know, 15, 20 minutes, depending on how much we want to add. And then we'll have some time for you guys to just get these things going on your own and start to add some stuff into the scene. Um, so I'm gonna take out the stuff that we have now and just start to like actually create a scene. So I'm gonna take out like my default cube that I added and take out the animation and stuff. Those are just kind of like demos basically, but we don't really need those in the scene that I'm gonna create. So I'm gonna take them out for now, but you can always obviously bring them back later if you want to. So yeah, I'm just gonna take these out. I was gonna go over like doing this stuff with like Git, but since Glitch does a lot of weird stuff with the Git, I'm not gonna go over that. Let's open up the terminal and just see. It's probably already logged this stuff. Yeah, it has. Uh, yeah, so we can see it's already added all this stuff that I added already. So there's no real point in trying to keep different copies of this. So I'm just going to go ahead and delete this stuff for now. Um, and we'll kind of start from scratch. Okay. So this is kind of my setup area. I'm going to put a little comment here that says setup. This is setting up like how the basic scene works. And we'll see different ways of doing this depending on how complicated our project gets. But this is a pretty basic setup. Like this will pretty much always work regardless of, what else you're doing with the scene. Here I'm going to make another little section and I'm going to call this like my scene. So that way I can kind of differentiate between where I'm doing the setup and creating the elements of the scene. What I'm going to do is just kind of create like a little simple nature scene with some trees and some clouds and a floor, like a ground. So something that'll just kind of set up a world that we can build into. And again, you guys could remix that as well and add stuff into it as well, or you could create your own version of this kind of simple nature scene. So I'm going to just start with the ground. So I'll put a little comment that says ground here. And to create the ground, I'm just going to use like a big plane. So I'm going to go over some different geometries for this. And I really want to use the documentation as much as possible. It's going to make it a lot easier for me to create stuff instead of having to remember how all the code works. It's really, especially when I'm working with Three.js, I do a ton of copying and pasting and just changing parameters. Um, so I'm going to go back to, okay, here we go. I'm going to go back here to the documentation, and I'm going to use for the ground, I'm going to use a geometry called a plane. So I'm going to click on plane geometry, and this is just like a flat surface. And so we're just going to create kind of like a baseline orientation for the scene. And you can see this is a very simple geometry. There's not a lot going on. It only has two sort of parameters, the width and the height. So if we change the width, it gets wider. If we change the height, it gets taller. And then we can also change how much geometry goes into this. This is something that we don't really need right now because we're just making a flat surface. But if we wanted like some mountains and stuff like that, we might want more points in the geometry so that we could add like different depth and stuff like that. So you can see as I add more segments, you get a lot more data that defines where this plane is, and then you could start to like play with those points in the middle if you wanted to do something like that. But I'm going to leave it as is. So I'm just going to grab my geometry, and actually I'm just going to grab this entire thing. So I'm just going to copy this whole thing over into my project. So this is the ground. I'm going to paste this here. And if we reload, we should see that plane. You can see it doesn't look like a ground right now because it's facing towards us. But it does have a front and a back because one of the defaults that's set here is the side is double-sided. So it does have a front and back, which the ground doesn't necessarily need, but it'll make it easier for us to see where it is in the scene. And so for now, we want to kind of place it like this, something like that. So we're just going to rotate it. So we'll just adjust the rotation. I don't know why these zeros keep popping up. What am I logging? That's kind of weird. Let's see. Huh. I guess that's something from glitch. More annoying things happening with glitch. Maybe they're like testing something. Okay, whatever. Let's go back to our console. So we want to rotate our plane. And then I also want to change the color. So I probably want to, for the ground, I want like a green color. I'm going to go to my HTML color codes. I don't know why I always use this site, but I feel like it's the easiest. And I'm going to find a green color. Maybe I'll do pale green. And I just want to take the hex value from here. So I don't actually need the hashtag. Just as a reminder, I can write the actual hex number into here. So when you want to change a color, just find the color. And there's a 0x, that's the beginning. And just take out this part and paste in the color that you want. And when we refresh, it should be green. Okay, and now we just want to rotate it so it looks like it's in the ground. Um, and I'm probably going to have to move the camera, but let's worry about that in a second. So my plane is just called plane. I'm going to change this to ground so I understand what this is. So when I created the plane, or when I copied the code, it's just const plane equals new 3.mesh geometry and material. So I'm going to change this to ground. And when I change ground, I have to make sure to also change plane here. So I'm going to put it there as well. So that's one tricky thing about copy and pasting a lot of code. You have to remember which parts to change if you want to update something. So now I just want to change the rotation. And since I'm working in 3D, it's a little bit tricky to remember how to rotate. But essentially, we want to remember that X goes this way and Y is up and down and Z is kind of like coming towards us. Okay, so if we want to rotate, right now our plane is like flat like this, and we want to rotate it like around the x-axis essentially, so it's actually lying flat on the x-axis. So we're going to rotate around x, and when we're rotating in 3D, we have to do it relative to pi. So remember, pi is the number that we use to measure the size of a circle. And 1 pi is 1/2 rotation, 2 pi is a full rotation. So if we want to rotate this, around x, we just say ground.rotation.x. And then here, this might be a little confusing, but this is how we do a lot of stuff in Three.js. We just use pi by itself, but pi in JavaScript is inside of this thing called math. So we can say math.pi. I think it's actually capital Pi, like that. And so that will do the rotation for us. So math is this like object built into JavaScript that has a lot of different things in it that help us do math, and pi is one of those things. It just gives us the number pi. So we're going to say ground.rotation.x equals math.pi. This should rotate 180 degrees. So what we're going to see when we first look at it is not really what we want. which is that it's actually rotated all the way around. We can't tell it because it's double-sided, but look if I take off the three dot double side and then refresh, it disappeared, right? This is another thing that's difficult with 3D stuff is that it's actually still there. You can see I just rotated it into view, but it disappeared because when I turned off the double side, most 3D meshes only reflect light on one side. And so unless we say it's double-sided, if we're looking at the back of it, we just are going to see right through it. So it's a little bit confusing. So I'm going to put that back. So I just say side 3 dot double side, and I'm going to refresh. So we can see all we did was flip it all the way around, but we really only want to flip it 90 degrees. So that's half of pi. So I'm just going to take math.pi and I'm going to divide it by 2. So I just use division by 2, and now we should have our ground. But notice again it disappeared. Okay, so this is going to keep happening as we first start to use Three.js. Where did it go? Well, it's just a plane, so it's completely flat. So if we're looking directly at it, we're not going to be able to actually see it. So this now has to do with our perspective. That's what makes 3D design kind of complicated. So right now, let's get rid of this. How do I just get rid of that. Okay, so right now we have our camera. Oh, whoops. We have our camera here, and we have a plane that's just like flat. And this is the y-axis, and the z-axis is looking at us. And then we can't see the x-axis from this perspective. Um, so the plane just looks completely flat because the camera is looking directly at it and it has no height. It has no dimensionality. So what we want to do is move the camera up here. And so now we'll be looking down at the plane. And so we'll have this like top-down perspective on it. So now we're going to set the position. So we're going to say, or wait, no, I got to do this on the camera. Whoops. I guess I could move the ground down, but let's say camera.position.y is 5. We already had that in here, so I'm just going to uncomment this. So I just hit command / to uncomment there. So now we can actually see our ground. We may want to move back a little bit farther on the Z so that we're not like at a direct like 45-degree angle. But we can play around with this and figure out what we want it to look like. So yeah, I'm gonna leave that here. Okay, so the next thing that we want to do is make the ground bigger. So right now it's just 1 by 1, so it's not very big. The dimensions in Three.js are kind of relative, so you can make stuff really small, you can make stuff really big, but it's about how they are relative to each other. So let's try making the plane bigger. So let's try doing like 100 by 100. So it'll still be square, but it should be pretty big. There we go. So this is starting to look more like a ground that we can work with. If we really want to make it so we can't even see the end, we could do like 1,000 by 1,000. Okay, so now it actually kind of just like clips into the horizon. Like we never see the edges or like kind of the triangle edges of the square. Okay, but we can, because of the orbit controls, we can kind of flip below the scene. So we might want to turn the double side off or maybe move our camera up a little bit. Let's try moving our camera up a little bit actually. So yeah, there's a little bit of a back and forth. So let's move the camera Y to like 50. Let's see what that looks like. Okay, now we're looking really directly down at the scene and I have to move up to look at the sides. So depending on what you want in your scene, you may try different stuff here. I think I went a little too high. I'm gonna do the camera Y is 10 and let's see what that looks like. Okay, actually I want to see a little bit of the horizon. So let's move the Z back. Actually, let's move the Z way back and leave the Y at 10. There we go. Now we can see the horizon. We can move around. You do see a little bit of like the edge of the square here, but it's not too bad. Okay, so we've got our ground. We can start to add like some little shapes and stuff in here. And there's a couple things that may be a little bit of review, hopefully, but I'll also just, try to go over them from scratch. So for today, I don't want to take up too much time because I want you guys to have some time to get started. So let's just add, what I think will be kind of easy, hopefully easy, is just to add some clouds. But we're gonna go over a couple of things as we do that. So we've got our ground, and now let's add some clouds. Okay, so for our clouds, we're gonna want more than one cloud. And so what I'm going to use for this is a loop. Hopefully you guys remember loops, but if not, that's okay. If we want to add a lot of stuff into the scene, the loop is going to make it a lot faster. If you don't remember the loop, I'm going to go over it, but it should have been something that you covered in MMP 210. Again, if not, it's not a big deal. We're going to go over it now. So we're going to talk about clouds and we're going to talk about loops. And another thing that we're going to go over is like how the different variables work together. So I'll give you kind of an example of that. So to make a cloud, I'm going to just start with some circles basically. So let's go back to our docs and let's look for in 3D, a circle becomes a sphere, right? A circle is just like a round shape. But in 3D, it has 3 dimensions. And so when we make a circle in 3D, that's called a sphere. So I'm going to look for a sphere. And we can see here I have sphere geometry. And so this looks pretty good. Okay, so we can see the code for this. And I can change the radius of the sphere. That's how big it is. I can change the width segments. That's how much sort of detail is in the width. So if I turn the width and the height all the way down, I actually end up with this thing that doesn't really look like a sphere at all because it just has, 3 segments and width and 2 segments height. So we probably want to turn that up a little bit. Okay, it looks more like a ball again. We can change where the rotation starts. We don't really need to worry too much about what this means, but we can kind of like take off a little edge of the sphere if we want to, or we can go to the other side like that, which is kind of cool if you want to do something interesting like that, but we're just going to leave these defaults. And then there's a length of these guys as well. So there's actually a lot we can do with this besides just creating a ball. But we really just want a ball. There's another way to create a sphere, which is could be better for like a retro style game or graphics, which is called an icosahedron. So an icosahedron is just a type of shape. But if we increase the detail a lot, we end up with something that's like sort of like a low res ball. So it's similar to a sphere, but there's less data involved, and so it doesn't take up as much space on your game, which is why this detail might remind you guys of like Nintendo 64 or other early 3D game systems because they wanted to save space and time, and so they could use this type of geometry to kind of mimic a round geometry. Okay, so I'm going to use these because I like how simple it is. I just have to worry about a radius and a detail. So it makes it a lot easier for me to create something, and it's ultimately going to run faster. So this is kind of a nice thing to use. Okay, so I'm going to grab this code. Oh, it actually doesn't have example, does it? No, there's no code example. Okay, so that's actually a good thing to go over. So if I want to recreate this, I'm going to have to figure out how to code it from scratch because there's no example here. So let's go to the new window. And oh, actually, what I really want is let's go to examples. No, they don't even have an example of this. Okay, wow. Okay, so we're going to have to figure out how do we do this. So what we're going to do is just compare it to other things that we've already created. So uh, let's let's just add a sphere. Or no, we can do this. So okay, so there's an icosahedron geometry, and it requires a float for the radius and an integer for the detail. And float is just a fancy word for a number with a floating point, like it can have a fraction or decimal. And a detail, integer is just a fancy word for a number that's a whole number. So like 1 or 2 or 3, like with no fraction or decimal. So I'm going to copy this part. This is not code. This is just like an explanation of the code. But I think it'll get me pretty close to what I want to do. So I'm going to go back to my sketch. And I'm just gonna, this isn't code, so I don't want to paste it directly in, but I'm going to throw it in here, and then I'm gonna copy the rest of my code and make something new. So I'm gonna grab this part from my ground and just copy and paste. And so one thing that we're gonna run into now is that notice I've created a variable geometry here, and I've created a new variable geometry right here. And in JavaScript, I'm allowed to actually do that if I was using var, but we're doing a slightly more sophisticated style of JavaScript where we use constants. And so what I really want to do is I need to change the name of the variable that I'm creating. So as we start to combine multiple examples, we're going to run into these issues where we're reusing code that looks the same, and that's going to give us some errors. So we can't have two geometries. So one thing that I'll start to do is give these things different names. So for this one, I'm just going to use cloud, and then I'm going to use geo as a shorthand for geometry. So I'll just say cloud geo, so that way it's not going to conflict with my previous version. And then here's the part that I need to change. So this isn't a plane, so I'm going to delete this part. And I know that this is the name of the thing I want, so I'm just going to copy this here. And then I know it takes two things, a radius and a detail. So I'm just going to put stuff in here. So I'm going to put one for the radius, and I'm going to put, I know from this that I need more detail. Like this is 5 detail, and this is 0 detail. So I probably want like maybe 1 or 2. Let's try 1. So we'll have 1 for the radius and 1 for the detail. Put a semicolon here. And now for the material, I want a different material. So instead of using material, I'm going to write cloud. I'm just going to say MAT, so material for short. And for the color, I don't want this to be double-sided because it has geometry. It's not a plane, so I'll delete that. And for the color, I just want white. So for white hex value, I can just put FF, FF, FF. That just means full, full, essentially for every color. So R, G, and B are all going to be full. So that's going to work for this. And now, instead of ground, I'm going to use the variable cloud. And now I just have to, this I can keep the same, but I'm going to replace this geometry with my cloud geometry. So I'm going to copy that and put it in here. And I'm going to replace this material with my cloud material. So I'm going to copy that and put it in here. And I'm going to delete this part for a second. And I'm just going to say scene.add cloud. Okay, so that was a lot of steps, but hopefully most of that made sense. Obviously, I'm recording, so if you need to go over it again later, you can, or if you have questions, we can go over it. But we should have a cloud now. I'm going to go to my app and reload. And there it is off in the distance, my little tiny cloud. But it's directly in the middle of the scene, so we need to give it a new position. So let's see, what could we do for our position? So here is where I'm going to add another concept that you hopefully have covered in MMP 210, but when I'm designing and I want to do something kind of interesting, but I don't really want to spend a lot of time on it, one thing that I use a lot is randomness. So I'm going to create a random value for the X, Y, and Z positions of the cloud. And this is kind of easy to do in JavaScript compared to other languages, but it's still a little tricky. So the way I'm going to do this is I'm actually going to define X, Y, and Z values and then put them into the cloud. So I'm going to say constant X for the X position. And I'll just say to make something random, I just use math. Remember math from math.py. There's another thing I can do called math.random. This is like random in P5, but it's in regular JavaScript. So I can say math.random, and then the tricky part here is that just gives me a value between 0 and 1. So let me show you guys what that looks like real quick. If I say math.random in the console, it just gives me a random value between 0 and 1. So it's always different, but unfortunately, it's very small. It's just between 0 and 1. And there's a pretty easy way to fix that. I can say math.random, but I can multiply it by a larger number. So our scene is like, I think my plane is 1,000 by 1,000, but let's just start with 100 by 100. So let's say it's 100. So now I'll get a value between 0 and 100 that's random. And I don't really need this whole floating point, so I could do something to get rid of it. I could say math.random times 100, and now I'll just get a nice plain number. And if I do that a few times, I'll have an X, a Y, and a Z. That this probably looks a little crazy since you were probably used to doing P5 stuff where they kind of simplify it for you, but hopefully that makes sense. So let's go back to our code. Okay, so we'll start with constant X. We'll say math.random times 100. And then actually, let's not floor it because it doesn't really matter that much. We'll just say math.random times 100. We'll say constant y equals math.random times 100. And we'll say constant z equals math.random times 100. Okay, so now we can set the position of our cloud. We'll say cloud.position.set x, y, z. And I need to remember to use the spaces for Three.js. And let's reload this. And okay, so now we have to find our cloud because it's random. It's way up here. So that may be farther away than we want. Okay, now let's see. Okay, now it's down there. Let's see. Okay, now it's up there. Now it's over there. Okay, so that's pretty good. That's not too bad. Let me remember where I put my camera. Okay, so my camera's 100 pixels away, so that's good. Or 100 away, and the Y is 10. So yeah, maybe 100 on Y is too big because I'm only at 10, so let's do like 20 on Y. And for X, I don't really care that much here, so let's try again. Okay, that's a little bit better. And then maybe let's make it a little bigger. But you might have already figured this out. If I want to have clouds of different sizes, I can also use randomness in the size. So that's the radius part here. So I can do that before I create my cloud. I can say constant radius equals math.random, and let's say times 10. And then I'll put my radius variable here. Okay, so let's reload. That looks kind of small. Oh, there's a big one. Okay, that's right near us. There's another one. Okay. So here's the last bit. So sorry, there's a lot of code in here. Hopefully it makes sense. We can go over it, uh, if you guys have questions. But now we're going to do the thing that's going to make this really fun, which is add in our loop. And so hopefully you guys remember this, but when we are doing a loop in programming, essentially what we're doing is we're saying we want to do something more than once. So this is how much code we need to create a cloud. That's kind of a lot of code just to create one cloud. So if I want to create a lot of clouds, I need to do something more sophisticated to add a lot of clouds into the scene without having to, write all this code all the time. So that's where a loop comes in. A loop is for any time I want to repeat something. Okay, so I'm going to write that here. Loop anytime I want to repeat something. I don't know why I'm writing in the first person, but whatever. Okay, so if I want to repeat something, this is how I do it. I start with the keyword for. Hopefully you guys remember that. And that is a for loop. So it's sort of like saying for this many times, do this. And inside the parentheses for my for loop is the conditions. Or I start counting in one place, and then how long I want to count for, and then how many I count by. So I have my conditions, and then I have a code block. So remember, we haven't actually used one of these yet, or no, we did for our animate function. When we have a new block of code, we use those curly brackets, and all the code goes in there, and that's how we say this is what's part of the loop. And then when the curly bracket is ending, this is no longer part of the loop. And so all I'm going to do is I'm going to put all of this code into my for loop, okay? And so all I did is copy and paste. You could also, it might be easier to do it like this, just take out one of the curly brackets and then go to the bottom and put the end curly bracket. And the nice thing about glitch and most editors, if I click on this curly bracket, it's going to show me where it ends. So that looks good. And then I can click on the prettier. Oh, I have some errors, so I have to fix this, but then I'll click on prettier to make it look good. So again, for my for loop, I need where to start counting is the first statement. So for, I'm going to say let I equals 0. Hopefully you guys might remember that. Hopefully you saw that last semester. That essentially just means I have this thing called I, and I'm going to start at 0. So I'm going to start counting at 0, and then I'm going to keep counting for however long I want. So where to start, then how far to count, and that we're going to say we need something to say when we get to this point, we're going to be false. So for this one, we're going to say I is less than, let's do 1,000 clouds. So we'll just add a whole lot of them in there. So as long as I is less than 1,000, keep going, keep going. And then our last statement is how many to count by. So you could count by 2. Normally we just count by 1. So we're just going to say I plus plus, and that means we're going to count 1 at a time. So for our loop, what's going to happen is we're going to start with I equals 0, and then we're going to make a cloud. And when we're done making a cloud, we're going to say, is I less than 1,000? And if the answer is yes, then we add 1 to I, and we go and we make another cloud. So 0 is less than 1,000, obviously, so that checks. So now I equals 1, and we make a cloud. So this is a little cloud. We make another little cloud. Is 1 less than 1,000? Yep. So I equals 2. We make another little cloud. 2 is still less than 1,000, and so we just keep going and going until we get to 1,000. And you can see now, whoops, now I can make 1,000 clouds with the same code that I used to make one cloud. So I'm just going to format this. Looks good. And a cool thing as well in JavaScript is I don't have to change any of this code. Even though I'm using these variables, they don't match any variables I've used before, and they're only going to exist inside of this for loop. So they're never going to happen again. And so hopefully I didn't screw anything up. Now we're going to get lots and lots and lots of clouds. So now I have to kind of adjust my numbers a little bit, but you can see now I have like 1,000 of these geometries, which is maybe too many. But now we have our nice little clouds. And so I'm just going to add a little bit more and then I'll be done. Sorry, I'm going a little longer than I planned to, but we're almost done. So now that we see our clouds, we can start to shape them a little bit. So one thing I can notice right away is that they're too close to the ground. And so I need to use a little bit of math to fix that. So I'm going to actually do less clouds so I can see a bit better where they actually are. Okay, so now I see a bit better where the clouds are. Okay, so they're too close to the ground is my first issue. And so the reason for that is if we look at our code, this is the y value. The y, remember the y-axis is the ground. So if this is our ground and this is y, whoops. If this is our ground and this is y, right now we're saying math.random times 20. So it's really anywhere between 0 and 20. So we could have a cloud here or here or here or here. But we probably don't want our clouds to start until they get to like, I don't know, 15, maybe 18 even. And so what we can do instead is just figure out where we want them to start and how far we want them to go, and then change our math a little bit. So let's say where we want them to start. Let's say it's 15, and let's say how far we want them to go is 5. So we want them to only be up here essentially. So we can change our math. So instead of math.random times 20, we only want them to be maybe around 5. But then if we add 15, they're all going to start at 15y, and then we're going to add a little bit of randomness. Okay, so you may be thinking, oh, this hopefully reminds me a little bit of doing randomness in P5, because hopefully you guys did a fair amount of that last semester. But now we're actually doing it ourselves. We're actually figuring out the math on our own. So when we're P5, we could actually use along with Three.js, but one of the nice things about writing pure JavaScript is you have to kind of think through how these things actually work on your own a little bit. So let's refresh this. And okay, now we have our clouds in the sky. So that's looking pretty good. And we could raise them a little bit if we wanted to. Maybe we'll raise this to like 25. Let's see if that looks better. Yeah, that kind of looks better. 25 seems pretty good. And maybe we want to spread them out a little bit more. So let's increase the x a little bit. Let's do like x times 200. Okay, that looks pretty good. Uh, and we can do z times 200. Okay, that's starting to look pretty good. Um, I think we can stop there. Hopefully this makes some sense. You don't have to do everything this way, but I think this is a good place to start. Um, okay, I think that's everything I wanted to cover. We're going to do a little bit more on Wednesday. We're going to add lighting and materials, and that's going to make our scene look a lot more realistic and more interesting. And it's actually not really that hard to do. There's just like a couple of things that we have to add in here. So again, this link is still the same. If you click on the link I added earlier, you'll see all the updated code. So you can always use the same link. The link doesn't change even if the code does. So if you want to go in here and look at this again, just click on the link that I added before. But yeah, I'm going to stop recording.